take a look at your 12.1 worksheet here. It says use the following table to answer the questions below. So it looks like we're comparing students here, seniors, juniors, and sophomores, and whether they drive to school or they take the bus to school. So in order to really answer all of these questions, one of the things that's going to be important for you to do is to get some subtotals and grand totals of the number of kids that are actually surveyed. So one of the things I'm going to do down here is write a total, and I'm going to count up, or I'm going to add up how many seniors there are. So 340 and 140 makes doesn't make 500, makes 480. Sorry about that. And then juniors, 210 and 340 makes 550. And then sophomores, 80 and 430 make 510. I'm also going to do total number of kids that actually drive to school. So I'm going to add the 340, the 210, and 80, which adds up to 630. And then I'm going to do the 140, 340, and 430. If I add those up, that adds up to 910. And then just to verify, I'm going to add up the number of actual students by class and by driving. These should both total and be the same and should add up to 1540. Because a lot of these numbers are going to be useful, or are going to be important when answering probability questions, because many of them are going to be out of these particular numbers. So, first question here then says, what's the probability that a randomly chosen student takes the bus to school? So I can just take a look here. Takes the bus to school, it's a randomly chosen student. So that's the 910 students out of the total, since we're talking all students, 1540. If you put that as a decimal on your calculator, you get about 0.591. On the second one, it says, what's the probability that a randomly chosen senior drives to school? So now we're just focusing out of all the seniors, so my bottom number is 480. I want the ones that drive to school, so we're talking those 340 right there. That's my top number. So 340 out of 480 ends up being 0.708. The next one is, what is the probability that a randomly chosen junior takes the bus to school? So now we're talking about our juniors. So we have a total of 550 juniors. We want to know how many of them take the bus to school. Well, that's 340. So 340 divided by 550, that ends up, takes the bus to school. So 340 divided by 550, let me just type that in, 340 divided by 550 ends up being 0.618. So 0.618. So junior takes the bus to school. Yep. So D. Let's kind of slide this up a little bit more. It says, what is the probability that a randomly chosen student who takes the bus to school is a sophomore? So the key piece here is it's out of the students who take the bus to school. So when I look at my bottom number, takes the bus to school, my bottom number here is this 910. The question then becomes, how many of those 910 students are sophomores? That's 430. So 430 divided by 910, 0.473. All right, the last one on this page, or it's not on this page, on this problem, says, what is the probability that a randomly chosen student who drives to school is a senior? So now we want to take a look at all the students who drive to school. So our total there, apologies there as it jumped on me there, we're talking a total of 630. Of those 630, how many of those are seniors? That's this number right here, the 340. So our probability would be the 340 seniors out of the 630 total that drive to school. So that ends up being 0.540. All right, that takes care of number one. Number two. Number two is going to be helpful if you go back to your notes from today's class lesson and look at that dice chart that has that dice chart where you have the numbers 1, 2, 3, 4, 5, and 6 by 1, 2, 3, 4, 5, and 6. So it has it sectioned out like this, and you're looking at the sum of all the dice. Now I'm not going to fill this whole thing in because you can refer back to it, but I'm going to try to at least point things out on it. So on the first one, it says, what is the probability that the sum of the dice is a 4? Well, if you look on your chart, this 3 and 1 is a 4, this 2 and 2 on your chart is a 4, and this 1 and a 3 sum up to a 4. So there's a total of 3 of them. We know by this chart it's 6 by 6, so that means there's 36 possibilities. Okay, so 3 out of 36 as the decimal reduces to 0.083 with the 3 repeating. B says, what's the probability that the sum of the dice is 9 or more? So a 9 or more would be like 6 and 3, 6 and 4, 6 and 5, 6 and 6. So all of those are possibilities. So is 5 and 4, and 5 and 5, and 5 and 6. And so is 4 and 5, and 4 and 6, and so is 3 and 6. So all of those are a sum of 9 or more. So we have 10 of them out of 36. That reduces to 0.27 with the 7 repeating. Question C says, what is the probability that at least one die shows a 5? So if I look at all of my 5s, okay, this would be 5, 1, 5, 2, 5, 3. So all 6 of these have at least a 5 in them. Likewise, going down the column, this 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, and 6, 5 also. Now here's the tricky part. Many people will want to go, well, I have 6 here and I have 6 here, I have 12. But the double 5 you don't want to count twice. So if you just count actual number of possibilities, you actually only have 11 of them there out of 36, which ends up being 0.30 with the 5 repeating. All right, our last one on this page asks you to, what is the probability that I roll a 6 or a 10? So we have to look at all of our 6s. So that's 5, 1, 4, 2, 3, 3, 2, 4, and 1, 5. So it's all of these going across this way. So I have 1, 2, 3, 4, 5 of the 5 6s. And then if I look at my 10s, which are written right here, 6, 4, 5, 5, 4, 6, I have a total of 5 plus another 3. So I have a total of 8 out of 36, which equals 0.2 repeating. All right, let's move to the second page. So we're putting these together. So number 3 and number 4, very similar to number 1 and 2. So just more practice with these probabilities. So again, it says use the following table to answer the question below. Now instead of talking about driving to school or taking the bus, we're just talking about male and female students based on the senior, junior, and sophomore class. So again, let's do the subtotals of each of the groupings because that's going to help us with these questions. So if I take a look here, if I add up my seniors here, I believe I have a total of 540. Juniors is also 540. Sophomores is 510. So if I do the other totals, total males is 730. Total females is 860. The grand total adds up to 1590. So now we can start to answer some of the probability questions based on this table. So it says, what is the probability that a randomly chosen student is male? So we have 1,590 total students. of which 730 are male. So if we add those up, or sorry, divide those, 0.459. B says, what is the probability that a randomly chosen senior is female? So if we look at our our seniors, total of 540 seniors, 310 of those are females. So 310 divided by 540 is 0.574. Look at the next one. What is the probability that a randomly chosen junior is male? Well, we have 540 juniors, 280 which are male. So 280 over 540, so that ends up being 0.519. D says, what is the probability that a randomly chosen female student is a sophomore? So we have, if I look here, 860 female students. So that's our total because it's got to be a randomly chosen female student. We want to know how many of those are sophomores. So that's 290. So 290 out of 860 is 0.337. E, our last question from this table says, what is the probability randomly chosen male student is a junior? So I'm going to look at all my male students, 730. How many of those are juniors? 280. So 280 divided by 730, and I get 0.384. All right, our last question says, using the rolling a pair of four-sided dice chart below, so just like the six-sided chart, here are all the outcomes, a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, all the way down to 4 out of 4. One of the first things I'm going to note here is how many possibilities I have. I have 16 because I have 4 possibilities times 4 possibilities gives me 16 total outcomes when rolling a pair of four-sided dice. So, question A says, what is the probability that the sum of the dice is 6? So I'm going to look at all my 6s here. So I look across here, 4, 2, 3, 3, 2, 4, all add up to 6, so there's 3 possibilities out of 16. That ends up being 0.1875. Question B says, what is the probability that the sum of the dice is 5 or more? So now if I look at all my 5s or more, you'll see that it's this whole area right here. It's kind of this triangle of our diagram, because this is 5, 6, 7, 8, 5, 6, 7, 5, 6, and 5. So we count all those up. If you take a look at 4 plus 3 plus 2 plus 1, I have 10 out of 16 possibilities, which is 0.625. C says, what is the probability that at least one die shows a 2? So if I look at this, I got to look at all my 2s. So similar to that last one on the front side, you can see that I have 4 2s here that I'm circling in orange, and I have another 4 2s here. However, I've counted this one twice, which I don't actually want to do. So I actually have a total of 7 out of 16, because I don't want to count that one twice. So I have these 4, and then 5, 6, don't count this one, 7 possibilities. So 7 out of 16 ends up being 0.4375. And then the last question says, what's the probability that I roll a 3 or a 6? So I look at my 3s. Well, the only way I can roll a 3 is a 2 and a 1 and a 1 and a 2. And the 6s I did earlier up in A, which I had right here, those 3. So 3 plus 2 is 5 out of 16. And so when I divide that out, I get 0.3125. So this ends your worksheet.